Welcome to this presentation for Design and Technology. I'll be taking you through the presentation. My name is Mukai Nyangara, and below my name indicated are my contact details and also the contact hours, which is 1600 to 1900 hours. The objectives of the presentations are as follows. Indicate resources students need to study to prepare for the exams. Summarize the course content, topics covered by the course. Explain the format of questioning. Highlight areas which presents challenges. Present key concepts students need to know. Discuss what is to be done when asked to draw. Work out examples of calculations. Discuss the use of examples and full explanations, and discuss the significance of mark allocation with regards to length of answer. These are some of the resources we need to consult for this course. We've got our main resource, which is the start guide. Then we have a textbook written by Manas, Shapalala and Hess. This textbook is a grade 10 learner's book for design and technology, which is published by Namibia Publishing House. Then we also have a textbook by Garrett, 2004. It is a design and technology textbook written by Cambridge University Press. Then we also have our assignment, question and answers. And we can also consult internet sources. Right, our first topic in this course is conservation measures and the safety precautions. Right, the first question is, what is conservation? And we need to know how to conserve natural resources such as trees, water, and soil. Then we have topic on reusing and recycling plastic waste. We have the 4 R's of recycling, which are reducing, reusing, recycling, and recovering. What is being a green consumer? We need to know what is being a green consumer. For example, if you engage in conservation, you become a green consumer. If you are using less plastic bags, you become a green consumer. Right, then we have conservation projects in Namibia. Right, we need to know these conservation projects in Namibia. Then we have types of emergencies and preparedness. For example, weather, non-weather, fires, and medical emergencies. Right, then we have got the NOSA safety regulations for industries, institutions, and schools. Then we also need to know how to dispose materials in safe and environmentally safe way. Then we also need to motivate our learners to engage in recycling projects. For example, collection of paper or collection of plastic bags. Right, then our next topic is design and design communications. Yes. Under this topic, we need to know what is a prototype. We should be able to define a prototype. Then we need to know steps in building up a prototype. Then we also need to know how to evaluate a prototype. For example, when we consider the correctness, learnability, the quality, These are some of the considerations when you are evaluating a prototype. Yes, then we need to know how prototypes are used in real life situations. For example, they can be used for research, they can be used for demonstrations, they can be used for testing new products. Then we also need to be able to do orthographic projections, the first angle side, top views, third angle side, and a top view. Then our next still under this topic, we have design communication. Yes, designing involves constructions. Designing are a way of communicating. Then we should be able to draw features using scale, where we are given a scale, for example, 1 to 100 or 1 to 50, meaning that if we say 100, 1 to 100, it means 1 unit on paper represents 100 on the ground. There could be centimeters, there could be millimeters. It will depend on the units we are given. So we should be able to interpret scale drawing. An example is a question may say a house measures 50 meters by 30 meters. Draw to scale using a scale of 1 to 500. Your scale drawing will be 100 millimeters by 60 or 10 centimeters by 6 centimeters. How do you find the answer? As illustrated there, you say 50 meters, or you convert to millimeters, which is 50,000 millimeters. Then the scale is 1 to 500. Then you divide by 500. Then you get 100 millimeters, which is 10 centimeters. You do the same to the width, 30 meters, you convert to millimeters. It becomes 30,000 millimeters. Then you divide by 500. Then you get 60 millimeters. And then you convert to centimeters, which is 6 centimeters. Yes, then when you draw, you need to be accurate. You need to be very, very accurate. Right, then our next topic is what to consider when designing a house. There are certain considerations when we are designing a house. We need to know our budget, of course, so that we don't do the project halfway. Yes, we also need to check the reputation of the builder. We need to get someone who will produce quality work. Yes, and then we need also to build with a resale in mind. Sometimes we may decide to resell the house, so we need to consider that. Then we also need to think green. How can we conserve the resources? How can we protect the environment? Yes. Then we also need to have extra cash, just in case. Materials may change, and if we don't have extra cash, sometimes we may leave the project uncompleted. Then we have 16 life home designs. These concern considerations so that you have a quality home. These are some of the things you should consider. You should consider the car park width. You consider the approach to the home. Then you should also consider the entrances. Sometimes you may buy something big, so your entrances should be big enough to accommodate that. Then under the same topic, we also have effective questioning techniques, and these you can get them on page 60 of our study guide. Yes. Right, then let's now look at electrical symbols, as you should be able to identify what these symbols mean. For example, the switch, that is the sign of the switch, then the sign of the cell, then the battery, then the lamp, then the voltmeter, then the ammeter, then we've got the resistor, then the variable resistor, and the motor. We should be able to identify and name these simple electrical symbols, right? Then we can use these electrical symbols to illustrate an electrical circuit. There illustrated is a simple electrical circuit. We've got the battery, we've got the bulb, we've got the switch. We have another one which is illustrated below again, showing the same thing. So if we switch on, the lamp will light. We switch off, it will also go off, meaning that we can complete the circuit using the switch, or we can disconnect the circuit using the switch, just like what we do when we are lighting in the house. Then let's look at the 4 types of stress. These, when we put pressure, yes, we have the tension stress, where you pull both sides of an object. Then we've got the compression, which is number 2, whereby you press from both sides, coming inwards. You compress. Then we have the shear stress, where you slide opposite directions. And then we've got the torsion stress, where you twist. I think these are clearly illustrated. Now let's look at materials. This includes wood and metals, right? We need to know the types of wood: mahogany, teak, etc. Then we also need to know the wood or timber defects. How to use a saw correctly. We need to know how we should use a saw correctly, how we stand, how we handle the saw, and protective measures or safety measures we need to take. Right. When using a lathe, a rotor, or a miller, or any power tool, when we say power, we mean any tool which is powered by electricity. Yes, we also need to know the safety precautions. Right. Then we need to know ways of treating timber against the fungi, also against weather and against insects. Then we have different types of joints in wood that we can make or we can refer to page 70 to 106 of our syllabus or our start guide. And we'll be able to get these different types of joints in wood. Then still under materials, we have metals. Important properties of metals, that those are 4 the properties or characteristics of metals: malleability, ductility, conductivity. Yes, we need to know these. Then when we are also cutting or sawing metal, what precautions do we take? Similarly to wood, the precautions are the same as the safety measures we need to take. Right. Then we have got different types of chisels and different types of screws as illustrated there. The blunt pinion, which is number 1, then the partial tapping round head, then we have the self-tapping round head. And if you look at these screws, if you look at the shape of the head, it's round, so the name is derived from that shape. And also, if you look at the threads, you can see that these ones are self-tapping. So it can help you, or it can guide you to identify and name these screws. Right. We said something on effective questioning techniques. How do we question students effectively? We should give learners time to think. Then we should always move from simple to abstract. I think this one is a norm in teaching, that we should move from simple to abstract. We should move from what the student know and then move on to something new, so that they can connect, the prior knowledge. Then we also need to ask one question at a time. We should avoid double barrel questions. Let's focus on one at a time. Yes, then we should not allow few learners to dominate. Even students who are not lifting up hands, they should also be given the opportunity to take part, not only those who are lifting up hands. Otherwise, at the end of the day, we may have only one or two students taking part. Yes, do not ask questions, do you understand? If you ask students and they say, do you understand? They will either keep quiet or they will say yes, even if they don't understand. To test that they understand, you should ask a question. Just ask one or two questions about what you have covered. Then you'll be able to tell whether they are understanding or not. Or you can just say, can you give us what we have covered? Can someone summarize what we have covered? Or can someone describe the characteristics of something like that? Then we have got wood finishes. Let's look at wood finishes. We've got surface coatings. These are high durable finishes and are maintenance free. Examples are varnish, shellac, and lacquer. They add depth and warmth to the appearance of wood. Right, then I think we are familiar with varnish. Then we've got pigmented finishes. These are not transparent. They look like paint, and also they can be bought in different colors, and they protect the wood against weather conditions such as the sun. Then we've got penetrating finish. It is like oil which penetrates into the wood. It provides a smooth surface by closing any small gaps and uneven surfaces. It creates a beautiful finish. However, it requires regular maintenance. Then we've got waxing. It also protects the wood. If the wood is getting old or appearing old, we can use waxing. Right. Then we have staining. It is used to enhance the true color of woodwork or to achieve uniformity. When the surface of the wood is inconsistent, it can also be used to change the original color of the wood. Then we've got glazing and toning. These they help to unify and add details to the color. Right. Then you can read further on these wood finishes on page 70 to 106 of your guide. Then the precautions you should take when sewing metal. Right, you need to stand correctly so that you can have balance. You need to lean forward a little bit. Then you also need to keep your eyes on the line so that you can cut straight. you need to use the correct blade. And make sure that what you are cutting is held firmly. For example, you can use a vice grip to hold firmly. And you should not rock or twist the blades, otherwise it may break. And the blade should always be vertical. Right? If you are cutting a thin sheet of metal, you support it with a block of wood so that it doesn't move. Do not exert or put too much pressure when cutting. You should just be gentle. Otherwise, if you put too much pressure, the blade may break. When you are cutting, you need to use the whole length of the blade. Do not use only the center part. Otherwise, your blade will get finished on one part. So you need to use the whole blade. Right, then that picture is showing the hydraulic system. We want to look at some of the advantages and disadvantages of hydraulic system. Right, the arrows are showing the parts of the hydraulic system. What are the advantages of hydraulic system? It is an efficient transmitter of power. Right, each simple levers and push buttons make it easy to start, stop, and accelerate. And these levers allows easy control of the machine. Right, also because it is such a fluid system, without any cumbersome gears, pulleys or levers, it easily copes with a huge weight range. Right, it can provide constant force despite or regardless in change of speed. For the most part, hydraulic systems are simple. They are safe, economical because they use fewer moving parts compared to mechanical and electrical systems. Hydraulic systems are also safe to use in chemical plants in the mines because they do not cause sparks. Most sparks may lead to fire, so they are safe. However, hydraulic systems also have got disadvantages. Yes. Handling hydraulic fluids is messy. It can be difficult to totally get rid of leaks in a hydraulic system. So we may have leaks of oil, which may be messy or dirty to handle. And if hydraulic fluid leaks in hot areas, it may cause or it may lead to fire. If hydraulic lines burst where the pressure moves, they can cause serious injuries. It means something may collapse, the machine may collapse. Then the other advantage is that hydraulic fluids are corrosive. Right? It means they create rust. Then to keep the hydraulic system in its prime or working, it needs periodic check for leaks, and it also requires lubrication and changing filters and seals as required. Then we have pneumatics. Yes. Pneumatics uses compressed air to produce an output. Illustrated are examples of pneumatics. We've got the pump, we've got the brakes of a lorry, Then we've got some doors of buses which use pneumatics, or doors of trains. Then we can also have the pump of a bicycle, as illustrated. The advantages of pneumatic system, right? It uses air. Air is the most important thing in the pneumatic system. And as we all know, air is available in the world around us in unlimited quantities at all time places. Air is a substance that is easily passed or moved from one place to another through a small pipe, the long and the winding. Then we also have flexibility. Then we also have safety. The air can be loaded more safely than it is. It's not flammable and does not short circuit occurs. Right. Also, another advantage is cleanliness. Unlike the grease in air is clean. And also the other advantage is the power and the speed. It's very easy to set up. The transfer of power through air is very easy to set up. You can refer to page 125 of your study guide for further advantages of the pneumatic system. Then we've got the disadvantages of the pneumatic system. Compressed air should be well prepared to meet the requirements or meet criteria such as dry clean and contain the necessary lubricant for pneumatic equipment. It is also easy to leak. The moment we have a small hole, the air will leak and the equipment will not work. Pneumatic using open system, meaning that the air that has been used will be thrown out of the system. Right, the air comes out pretty loud, so we are looking at potential noise. Right. Then look at the cells. We've got two types of cells, the primary and the secondary cells. So let's look at the primary cells. Illustrated are the primary cells. We normally use them maybe in a torch. A primary cell is a battery which can be used only once, as they are not rechargeable. Right? A new primary cell can generate power through the battery, but when the chemical reaction in the battery cell stops working, it cannot produce power or electricity. After using the primary cell, we throw it away. They are dry batteries. A flashlight battery or dry cell is made of zinc shell that serves as the anode and graphite rod which serves as the cathode. Right, so these are primary cells. Then on the other hand, we have secondary cells. A secondary cell is a battery which can be used many times. The secondary cell can be recharged. Secondary cell usages include emergency, no fail, and standby power sources. Right, if we look at the illustration, we can see that the secondary cell is a battery which we use, for example, in cars. Right. The secondary cell should be maintained regularly and should be recharged in a periodic manner. They have high discharge rate performance at heavy loads. The overall inherent adaptability of secondary battery systems permits its use in continuing research for an enormous spectrum of applications. And we've come to the end of the presentation. Thank you all.